Welcome to Analog Communication playlist. Here in this session, I will be going to explain the multi-tone amplitude modulation technique. So we have already seen amplitude modulation for single tone, right? Now in this session, I will be going to explain amplitude modulation for a multi-tone signal. So first, we need to know what is a multi-tone modulation. Now, a multi-tone amplitude modulation is that type of modulation in which the modulating signal consists of more than one frequency component. That means if my message signal consists of more than one frequency component, then the modulation of that signal will be known as multi-tone modulation signal. Okay, clear? In previous session, I have discussed the modulation where my message signal consists only one frequency component, that is FM. Here in the multi-tone modulation, we will discuss where my message signal consists more than one frequency component. So let us consider the carrier signal first, and we consider it is A cos omega ct. Okay. Now we consider that this carrier is modulated by a message signal or modulating signal or baseband signal, all are same, xt, where xt is consist of three frequency components: v1 cos omega 1t plus v2 cos omega 2t plus v3 cos omega 3t. So now my message signal consists of three frequency components. Therefore, the modulation of this kind of signal will be known as multi-tone modulation. Now, first we know that the general expression of AM signal st is equal to a plus mt cos omega ct. In previous session, I already derived how we can determine the general expression of AM signal. If you want to learn or if you want to see the derivation how we can derive this expression, please go through my previous session. So we just simply expand this expression. So my equation will be a cos omega ct mt cos omega ct. Therefore, now we just putting the value xt in my AM signal expression, general AM signal expression. So here my message signal is, just if we directly put, then it will be a cos omega ct plus v1 cos omega omega 1t plus v2 cos omega 2t plus v3 cos omega 3t into cos omega ct. Now if we take common and if we rearrange, then my message signal will be modulated signal will be a into 1 plus v1 a cos omega 1t plus v2a cos omega 2t plus v3a cos omega 3t into whole bracket cos omega ct. This will be the expression of multi-tone modulated signal. Okay. Now we all know that modulation index is maximum amplitude of modulating signal by maximum amplitude of carrier signal. In previous session, I already explained the significance of modulation index, different if you want to know the modulation index total, the significance and everything, you please refer my previous sessions. So finally, the multi-tone modulated AM signal can be written as A plus M1 cos omega 1t plus M2 cos omega 2t plus M3 cos omega 3t into cos omega ct, where M1 is the modulation index 1, that is V1a, M2 is the modulation index 2, V2a, and M3 is the modulation index 3, V3a. So here we can see if my modulation is a multi-tone kind of modulation, then instead of one modulation index, we will get many modulation index based on how many frequency component exist in my message signal. Okay. Now we simply expand this expression. So we just multiply it. So if we multiply, we will get a cos omega ct, that is my carrier signal. Then m1 a cos omega ct plus cos omega 1t plus m2 cos a cos omega ct plus cos omega 2t plus m3 cos omega ct plus omega c. Okay, so this will be the final expression. Now we know it is cos a cos b. Now if we consider it is my signal is a sine signal, then we'll get this kind of expression. That means here it will be cos a cos b. So omega c plus omega 1 means fc plus f1. So omega c plus omega 2, which is cos a cos b. So omega c plus omega 2 and cos omega c minus omega 2, cos a cos b plus cos a minus b. We know the formula, right? So similarly we will get omega c plus omega m, omega c minus omega 1, then omega c plus omega 2, omega c minus omega 2, and we also get omega c plus omega 3 plus omega c minus omega 3. That means we will get many USB and LSB like this. So if we put the spectrum of this, so instead of single tone amplitude modulation where we get only one USB and one LSB, in a multi-tone amplitude modulation we can get many USB and many LSB. So here we can clearly see, if we put the spectrum of this example, then FC plus FM1, FC minus FM1. So second USB FC plus FM2, second LSB FC minus FM2, third USB FC plus FM3, and third USB FC minus FM3. In this manner, the spectrum of an amplitude modulated signal can be drawn. Okay. Now we will determine the another important thing, that if my signal is a multi-tone amplitude modulated signal, then how will can determine the total power of this signal, right? In previous session I have already derived the power requirement, that is total power, sideband power, carrier power, everything, and we also determine the efficiency, power efficiency, transmitting power efficiency for single tone amplitude modulation. If you want to learn, or if you want to see, please go through my previous sessions where I have covered these things um, elaborately. Okay. Now in this session we will determine the total power for a multi-tone M signal. Now the total power means we know that it is the carrier power plus sideband power. So we first determine the carrier power, that will be a square by 2, very simple, and we will determine the sideband power. Okay. So total sideband power, if we determine, then we will get that it is 1 by 4 a square m1 square plus m2 square plus m3 square. We all know that where m1 is b1 by a, m2 is b2 by a, and m3 is b3 by a. So now the total power will be PC plus PS. We have already determined the total carrier power, that is a square by 2, put it, and we have already determined the total sideband power PS, that is 1 by 4 a square m square m2 square plus m2 square. We put, and if we determine, if we simplify, then we can get the total power, transmitting power for multi-tone M, that is PC into 1 plus m1 square by 2 plus m2 square by 2 plus m3 square by 2. Previously, in previous session, we have seen when we derive that total power for sideband, total power of a single tone amplitude modulation is PC into 1 plus m square by 2. That means only one modulation index is there. Now in total power for sideband, for total power for multi-tone amplitude modulation, there are number of modulation index. So it is, the formula is converted from 1 m square by 2 to, from m square by 2 to mn square by 2 plus m2 square by 2 plus m3 square by 2, because here we have considered 3 frequency component. Now if we expand it, and if suppose n number of frequency component, then this formula can be written as that Pt is equal to Pc into 1 plus mn square dot 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 mn square by 2. So if we more compress or simplify this equation, we can write Pt is equal to Pc into 1 plus mt square by 2, where mt is the total modulation index. That means how many modulation index are there? From there we can determine total modulation index. And total modulation index can be written as square root of the summation of the individual modulation index square. What I have told, that it is the square root of the summation of the individual modulation index square. That means mn square plus m2 square dot 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 mn square. Okay. So this is the total power we can determine by for a multi-tone amplitude modulated system. Now we will cover in this session some numerical problems. These numerical problems are very important for any competitive exam as well as for BTech courses. Okay. So take for the first numerical. Okay. So first numerical is where AM is a wave with peak on a modulated carrier voltage VC is equal to 10 volt and a resistor is 10 ohm. Modulation index is also given, that is M is equal to 1. Determine, they have a power for carrier signal, upper sideband, lower sideband, total sideband power, total power and also power spectrum. So all these formulas I have covered in my previous sessions, and also I have shown how we can plot a power spectrum for a amplitude modulated signal. So if you want to see, please go through my previous sessions. Okay. So this numerical here, the modulation is single tone. So all the formulas we will apply here will be for single tone modulation. So we all know already, we have determined these formulas in my previous session. So PC is, we all know, VC square by 2R. So VC is given to you, that is 10 volt. So 10 square is 100. 2 into R is 10. So it is 10 100 by 25 watt. So we will get the carrier power. Now second, they ask that upper sideband, lower sideband power. We know that upper sideband and lower sideband power are same and is equal to, we drive the formula. Please go through my previous session, that is m square PC by 4. So m is the modulation index, that is 1 square PC we have determined 5 watt by 4. So it will be 1.25. Total sideband power is nothing but PESB plus PULSB, or you can put direct formula, that is m square PC by 2. So 2.5. Now the total power. Total power, we know the formula. We have tried, we have seen in my previous session that PT is equal to PC into 1 plus m square by 2. So PT is equal to PC is 5, 1 plus m is 1. So we will get 6.5. Now lastly, the power spectrum. So we can draw the power spectrum in this manner, where the amplitude domain is the power and x-axis will be the frequency. That means the y-axis will be the power and x-axis will be the frequency. So first FC, the carrier frequency is power is maximum 5 watt. So we plot. Then PUSB, we have determined power is 1.25 for PUSB and PUSB both have the same power, so same height uh, we draw, and it will be lesser compared to my carrier frequency. So this will be the smaller one. So this is the power spectrum. Okay, clear? So this is the first type of example. Now go to the second example. Consider an AM signal tuning a carrier voltage 10 volt and modulating signal with an expression is given, that is 5 cos 2 pi 10 to the power 3t. Find the peak envelope power of AM signal. Okay. So they ask to determine the peak envelope power. So first we need to determine maximum voltage. So in my previous session I have already shown you in modulation index session, where we have determined I have defined the significance of modulation index, the Vmax, Vmin, where we have explained that we have seen that Vmax is equal to Vm plus Vc and V minimum is Vc minus Vm. So here we need the maximum voltage, so Vm plus Vc. So what is Vc? Carrier voltage, that is given to you 10 volt. And what is Vm? The maximum modulating index voltage, that is 5. So Vmax is 10 plus 5, that is 15 volt. Now peak envelope power obviously it is 50 square by 2. So it is a simple example, but we need to know the Vmax and Vmin. If you want to learn or see, please go through my previous section. Now the last numerical, it is very important, it is very much important in this type of numerical asked in competitive exam as well as your BTech curriculum. Okay. Now this example for multi-tone modulation. Now here, first read the question. The output current of 60% modulated AF generator is 1.5 ampere. To what value will this current rise if the generator is modulated additionally by another audio wave whose modulation index is 0.7? So previously my modulation is a single tone, where my modulation index 0.6, and total current is given 1.5, right? Now second part, another audio wave, that means my signal become multitone. Two signals are there, and where the second signal modulation index is also given, that is 0.7. So let's determine. So first M1, that is given 0.6, and total current, that is given IT is equal to 1.5. So from there we can determine the carrier current, that means IC. Okay, so IC, that is PT is equal to IT is equal to IC into 1 plus m square by 2 root over, right? Now if you want to know the current formula, please go through my previous sessions where I have discussed the power formula, current formula, everything. Okay, you will learn everything. So IT, we can write IC into root over 1 plus m square by 2. Now IT is given to you, that is 1.5. IC, remain IC, 1 plus m square is given to you, that is 0.6. So 0.6 square by 2. So IC will be 1.39 ampere. Okay, now the another audio wave is added, okay, and whose modulation index 0.7. So now M2, that means second modulation index is there, that is 0.7. So we know in this session already we have tried the total modulation index, how can determine. So MT is root over M1 square plus M2 square dot dot Mn square. So here two modulation index, the formula will be root over M1 square plus M2 square. So first M1 is 0.6 square, second M1 M2 is 0.7 square. So we will get MT is 0.92. So total current now will be, we can determine IC into 1 plus MT square by 2 root over. In this session we have determined, right? So MT square, what is MT? That is 0.92. Put 0.92 and we will get IT here because IC remains same. So IC is 1.39, put 1.39 ampere, 1 plus MT, put 0.92 whole square, and we will get the total current for the additionally added, that is 1.65. So I hope that this session it is clear to all that how we can determine the total transmission power for a multi-tone M signal. We can also have seen, go through different examples of different numericals, okay, which are very much important for your competitive exam and your BTech curriculum. So thank you for watching this video. You can write your suggestion, queries in comments. I will definitely try to get back to you based on your suggestion and queries, and you can suggest that those videos which is required to complete the analog communication engineering. Okay, so thank you once again for watching my video. God bless you all. Thank you.